Okay, number 4 looks like a tough arithmetic problem because you're given a 10th degree polynomial and they want you to evaluate this at f of minus 1 plus root 2. So I'm near the whiteboard and I want to try to come up with an easier way of evaluating it. So I'm given f of x, and again this is number 4, and that's going to be x10 plus 2x9 minus 2x8 minus 2x7 plus x6 plus 3x squared plus 6x plus 1. And I want to evaluate f at minus 1 plus root 2. So I really kind of reduce the complexity of the problem. And what I'm going to do is I'm going to try to take f of x and divide it by some polynomial. And we'll talk about what the polynomial I want to do later. And this would be equal to some quotient plus some remainder. Now if I did this, I could say f of x is equal to q of x times g of x plus, whoops, I'm sorry about that. This is going to be remainder over g of x. Okay, what would be nice is to make this thing 0 at the number minus 1 plus root 2. And to reason that, I want to do f of minus 1 plus root 2. And that's going to be q. It's going to be truly difficult to evaluate. G. And this is going to be r. And hopefully r is going to be easier to evaluate. I want this to be 0, by the way. So I'm going to look for the simple way to do it. You can do a linear equation, but I'm going to think to myself, I could probably do a quadratic and make it a little bit smaller. All right? So I'm going to say g of x is a quadratic. You could make it linear, by the way, but I'm going to make quadratic. With the understanding that a, b, and c are real numbers. And I want this to have a root. The root I want it to have is minus 1 plus root 2. Now, by the way, if the real coefficient polynomial, this would have a conjugate. So it would be minus 1 minus root 2. So I'm going to put g of x down for you. And that's going to be x minus this root, which would be plus 1 minus root 2. And then x minus this root over here, so plus 1 plus root 2. I need to multiply that out because I have to divide, by the way. And what do you get there? X squared plus x plus root 2x. Then what do you get? You get plus x plus 1 plus root 2. That's done. Then what do you get? Minus root 2x minus root 2, and then minus 2. Let's write this down. You get x squared, 2x. These disappear. These disappear, and you get minus 2. Oh, minus 2 plus 1. Sorry about that. That's going to be minus 1. All right? So g of x is x squared plus 2x minus 1. And this has the following roots, by the way. The roots of this polynomial, we just did it, right, is going to be minus 1 plus root 2. And the other root is going to be minus 1 minus root 2. All right? Maybe I should verify that. And you're going to get x equals, quadratic formula, by the way. This is going to be 2 minus 2 plus or minus the root of, let's see, b squared 4 minus 4a let's see, 2 minus 2, b squared is 4 minus a minus 4 is plus 4. You get x equals minus 2. That 4 plus 4 is 8. That's 2 root 2 over 2. And what do you get over there? Minus 1 plus or minus root 2, which is minus 1 plus root 2 minus 1 minus root 2. Yeah, this works out fine. So this is what g of x is. I'm getting my eraser out now. I was just checking it to make sure I did everything okay. And I got to get my eraser. All right, let's not lose track of what we have to do, by the way. What I'm going to do now is I'm going to take f of x. I get divided by g of x. I will get a quotient, and I'll get a remainder. Then I'm going to multiply both sides by g of x, and you get q of x times g of x plus r of x. Now I'll tell you what I want to do. I want to evaluate f at minus 1 plus root 2, which would equal q minus 1 plus root 2 times g of minus 1 plus root 2. And then the remainder, this is really complicated, doesn't it? Minus 1 plus root 2. But what I know about this over here, this is going to give me a 0 because this is a root. So really, f of minus 1 plus root 2 is going to equal the remainder evaluated at minus 1 plus root 2. All right? Now, I'm not saying the remainder is going to be easy to deal with, but it's going to be easier to deal with than f. So let's write this down. What was g? Again, my goal is to get the remainder. G is x squared plus 2x. Oops, not. It's minus 1, right? Yeah, minus 1. And I need to divide that into that crazy looking polynomial. But my goal is to get the remainder, by the way. And I got to look back over this to make sure I'm copying the polynomial correct, because a lot of times I miss a term and all of a sudden things go haywire. x10, 2x9, minus 2x8, minus 2x7, x6, 3x squared, plus 6x plus 1. Let's go through it. I'm going to say x8. And what do you get there? You get x10. Plus 2x9 minus x8. All right, I got to subtract now. And what's nice about that, the first two terms disappear, and I'm left off with minus x to the 8th power. And I got to drop the other terms down now. So minus 2x7 plus x6 plus 3x squared plus 6x plus 1. And I'm going to say minus x6 now. Minus x8. That matches. And then you get minus 2x7. And then you're going to get plus x6. Well, isn't that convenient? What do you get there? 3x squared plus 6x plus 1 plus 3. Let's see what happens. 3x squared plus 6x minus 3, and the remainder is 4. This is going to evaluate the 4. The remainder is 4. This remainder is 4. What's this function going to evaluate to? The number 4, and we're done. Thank you.